We good to go? All right. Welcome everybody. I'll be talking about Docker today. So thanks for joining me here, Dorothy and Michele. Before we begin, people who want to ask questions can do it on the YouTube channel or on Twitter and on this channel. I have this channel open on my iPad so I can see things coming in. I'll be using that channel too later on to post some links so you can all test some things out. So, what is Docker? I'm going to be talking about Docker in general. I'll be showing you how to use it. Later on, I'm also going to talk about some tools you can use with Docker and some third-party tools that are available. So a little bit about security, and yeah, it's going to be fun. So, what is Docker? Docker has three main things. It allows you to build, ship, and run applications. So, the first thing you do is you build a container. I will tell you a bit more soon about containers. Then you can ship this container. Then you can run this container. It has all these kind of tools to do this. So, what is a container? A container contains your complete runtime environment, including the application and its dependencies. And it will work the same on any environment. It kind of feels like a virtual machine, but it actually isn't. But it has all the same properties. Just it has a shell you can connect to. It has its own namespaces for file system. It has its own network interface. It can have its own users. It can run stuff as root. It can run services, and it can you can install packages onto it. So now you may think, so okay, what's the difference? So how does this compare to a normal virtual machine? So if we go back to virtual machines and look at those, so you have your infrastructure, and you have your operating system, like I don't know, Windows Server or Unix, and then you have your hypervisor, like a VMware or a VirtualBox, that manages all your virtual machines. And each virtual machine contains a guest operating system, and it's for its and the application and its dependencies. And if you want to scale that virtual machine, you have to take the complete image and replicate it, including replicating the guest operating system. So, with containers, you have also your infrastructure, of course, but you just have your kernel, so just your usual Unix, Linux kernel, and your containers run right on top of it. So they don't need a guest operating system, they just use the same kernel. And there's a daemon running on that host. In our case, that's the Docker daemon, which kind of manages these containers. So if you want to replicate this and boot a container, it goes much faster because you don't need to have a guest operating system installed on the container. So it's much smaller and much faster to boot. So let's talk a bit about the architecture and what the main components are of Docker. So this is a basic Docker workflow. You can see three main parts. You have your client. This is you. This is you doing some Docker instructions. You have your host. Like this can be a virtual box on your machine, or it can be a server, which has a Docker daemon running. And there's a registry. And the registry is like the repository that contains the images. And images are like the images of a virtual machine. And when you spin up a container, it takes an image and it creates a new version of it. So the Docker host, let's go by the components one by one. Docker host contains the daemon. It can be talked to by the client by a remote API, RESTful service. And it can be talked to through a socket or through a HTTP. And it downloads and runs the container. So that's what it does. So if you run a container, it's on a Docker host. Docker client, this is you, just talks to the daemon on the server. Then you have your registry, which is the image repository, and you can get there's multiple versions of it. So you have the official registry available at hub.docker.com. Anybody can create an account in there and publish public images. You can also go to the guys of Docker and say, hey, I want my own registry. I want you guys to host it, so they also offer it as a service. Or if you're like an enterprise and you want to host one on for your own on-premise, then you can go to a GitHub repository and start hosting your own by downloading it and then running it by yourself in a container, of course. So what's a Docker image? So it's the base for each container. So if you replicate a container, if you start a container, it takes the image and starts a new one. And it's made out of layers. So let me give you an example of layers. So each image consists of the following layers. So you have your boot FS layer. You don't actually see this anywhere if you're using Docker. It's there, but you don't see it. It's just the kernel that you're using. So this is actually always the same for all the containers running on the same host. Then what you can do is, for an image, you can select the base image. So for example, you can take Ubuntu. That's an image that's available in the registry. You can just take it and start from there. So if you start from there, you say, okay, I install Java 8 on that. That's a new layer. Then it creates a new image with that additional layer. And then you can install your application. And it creates another layer. And when you spin up a container, you actually get another layer, a writable container layer. This does not belong to the image, but belongs to your container. And when you stop the container, the layer is thrown away. So you have to keep that in mind if you're running an application inside a container, it's writing some data away, like a database or whatever. You need to make sure it's available somewhere else and not inside the container only, because else your data will be thrown away. The cool thing about these containers, these layers, as of Docker 1.10, which was released last week, they used to have random UUIDs. That caused some problems. Sometimes some IDs collided and stuff like that. And they couldn't really figure out what, okay, this layer, is it the same as this layer? We don't know. You would have to check every file in there and stuff like that. So what they did now with the latest version last week is they check the content and they create a secure hash using SHA 256. So it's a content-based hash. So if you create a layer, so you install Java and just creates those files and you do it again inside another image in a different order, then it will notice, oh, it's the same, and it's going to reuse that layer. So your image is going to be smaller, and yeah, it's going to be reusable. So what they also did, so because of this, they separated the images and the layers. So before 1.10, the image and the layers were kind of together. Like I said before, there used to be sometimes a problem with ID colliding, so they fixed that now. And of course, you're going to have better data integrity, because if you get the hash based on the content, then you can, when you download the image or you push the image, then you can check, hey, is it still the same as how it's downloaded or uploaded? So you're going to have better data integrity. And if you're running Docker before last week on 1.9 or whatever, and you want to go to 1.10, you have to migrate all your images, by the way. So keep that in mind as well. Let's see. Okay, so volumes. So as I said, that writable container layer is thrown away when your container stops. So Docker provides volumes, and they allow you to write and read data from outside the container. By default, if you're just mounting a local folder from your host, you can only do it from local folders. So no mount points like an SMB or FTP mount or whatever, you can't mount on those because Docker will consider that insecure. So it's going to complain and say, hey, I can only mount local folders. But of course, if you're going to like Amazon Web Services or whatever, you're going to have your data stored somewhere else, like on an EBS and so on. So they allow you to use what they call volume drivers. So it's kind of like sort of pluggable system that you can use. You can also write your own to mount volumes onto the container. So those are the main basic components of Docker. Now let's actually just get into action and just show Docker. Okay. So let me check. I'm first gonna check which machine I'm on. So okay, so I'm on my demo machine. So I've got this presentation that is a Reveal.js presentation and just a static website. And if I want to host it inside a container, I'm gonna need a web server. So what I can do is, for example, just look at hub.docker and just look for web service. Now I know there's a web server called Nginx. So you can see there they have an official image called Nginx, and when you click on there, you can see the explanation how to use it and all that stuff. Alright. So I already prepared a small Nginx configuration, so it's gonna copy it. Okay, so this is my configuration for my Nginx. So it's just gonna listen on port 80 and start some worker worker whatever. So if I want to run Nginx, I can just do this. Now, the first thing it's gonna do is it's gonna download it. There we go. So the first thing you see is it downloads every layer that's available from that engine, Nginx. Just finished? No. Yeah. I think it's maybe a bit slow with the live stream. Okay, that's like really slow. Is it? Is it doing anything? Right. Let me check. So, do I have the image? Okay, so I have the image. It apparently just stopped working. Okay, so now. Oh yeah, I know. It was started with Nginx and it attached the thing onto my terminal. So now it's stopped. So if I look at Docker at all my containers, you can see I had a container called with the image Nginx, and it exited a few seconds ago. Now, of course, I want to put my website in there, my presentation. So first thing I'm gonna do is I'm gonna run the container detached, so it doesn't attach it to my terminal. So next thing I'm gonna do is I'm gonna mount. So I'm gonna create some volumes.
So the first volume, I'm gonna create this. So I'm gonna take my local folder. So that's where my presentation is, and I'm gonna say mount it onto the. I think it's here. Mount it onto the container, and I'm gonna mount my Nginx config. And it's gonna be right here. I'm gonna give it a name, like my presentation. And I'm gonna say, oh, it's not yet related. Nginx. There we go. So if I go to, with Docker PS, you can list all the running containers. So you can see there's an Nginx running. Can you read this, by the way?
That's good.
Okay. So I can see, I can't reach it yet. It's running in a container, but it's not available yet because it has those ports, but I did not tell them yet to go to my host. So you can the default thing that Docker does, so you can expose some ports from container, but you need to manually still say, I want this port to be available on that port. So I'm just going to stop my presentation. You can just do it with Docker stop. I'm just going to remove it. My presentation, of course. And then I'm going to start it again. I'm going to say I want it to be available on port 3333, for example, and I forward it to the port 80 on the container. There we go. Now I'm going to ask the IP of my machine. So this is my Docker host. If I go to the port 3333, then I just get my engines for some reason. So probably it's something wrong. So user chair. Yeah, almost right. Just call it my presentation 2. There we go. There we go. Now my presentation is run inside the Docker container. So, of course, we don't always want to write these commands. It's really, you see, it's like 3 lines, 2 lines already. So what you can do is you can create a Docker file. And we're gonna do that here. Already did it, so I'm just gonna do it. So what you do here, you can you always start with from, then you say this is my base image. So in the presentation I showed you can take Linux or whatever. There's also like Java and whatever, and you can define a version here, but I always just take the latest. And you can do multiple things. So the first thing I'm gonna do is copy my folder to the same folder. I'm going to copy my configurations. And that's it. Because Nginx already has a lot of things already inside that his Docker file, I don't need to define a command or other parameters. It does everything for me. Now what I need to do is build it. So you can just do Docker build. I'm gonna tag it as there you go. And I'm gonna say build it in this folder. So this dot means this folder, and it's gonna look for the Docker file in there. So now it's sending everything to my Docker host, and it starts building everything step by step. So the first step was, of course, start from Nginx. So that's a existing layer. The second layer is my presentation, added, and then it copies my config. And now I have, if I look at my images by using Docker images, you can see I have an image called Tom Verelst / presentation. And all I need to do now is do pretty much the same. Do some port forwarding, like 323 to port 80, detached preferably. Give it a name, my container, and then just give my own image, and there we go. So that's it. That's basic Docker. You can, with these few commands, you can do pretty much everything already. So if you go back, so commands, just gonna go over them once again, so just so you know them. So the Docker file is a file that has all the instructions to create your image, and each step is cached for fast reuse. So if you put something after that second line, it will, and you build it again, it will just like, okay, I've done this already, oh, okay, something new. And then it's like, okay, I've done this already, so it's really fast. You have like an entry point command, which means this is the command is gonna execute. You also have a CMD command, and the difference between those is the entry point is the thing it always executes. So you can say, for example, nginx, and with CMD you can give in the parameters, the default parameters, and these you can override with the docker run command. So if you want to build it with that Docker file, just say docker build. If you want to run it, just choose docker run, give it a name, pass in the name of the image. If you want to stop it, just use stop. Start it again. So with those few commands, you can pretty much start a lot of things already by using the registry. If you want to manage them, ps lists the running containers. PS with the flag A for all. List all the containers, including stopped. By the way, if you have a question, just raise your hand and feel free. If you want to view the images, Docker images. If you want to remove an image, it's nearly the same as a container. So instead of rm, you have to type rme for image. And if you want to push Docker images, which I have not done, just do it after this. What you first need to do is use, if you have an account on the hub, you can just type docker login. It will ask for your credentials. You just log in, and then you can just push it. What you have to do here, it's a little mistake. You have to add your account name before the account name / before the image name, or else it will say, hey, that's not yours. So how do containers really work? So because they run directly on the kernel, but how does the kernel do this? So some people think like, hey, it's just magic. No, but it's not like that. So I find it important that if you're using a technology, that you actually also know what's lies beneath it. So I figured this out. It's not actually that complicated, but it's very low-level Linux stuff. So if we go back to 2007, kernel 2.6, whatever, they introduced a few new features. The first one called control groups, or also known as C groups. And these allow you to group certain processes and do kinds of stuff with it. So let's just talk about that in a bit. And the second thing they added were Linux containers, so you can see where this is going already. And the Linux container is just a normal package that you can install on a Unix, and it uses these C groups. So these control groups, what can you do with them? So the first thing you can do with them is limit resources. So
You can say, I want this process or this set of process only use about half of my CPU, or I only want them to use 1 GB of memory. Or you can say, like, I want this process to write 1,000 I/O operations per second max or something. You can limit everything of resources. We can also do prioritization. So we can say, okay, you can say, okay, this process is a bit nicer. So we can let processes use the CPU before them. Like, okay, let's just go, I'll just chill. Or you can be very aggressive. No, you wait, I'll do it. So, has anyone ever used the nice command yet in Unix? Okay, one person, awesome. So it actually uses the C groups prioritization to do this. So, third feature of control groups is accounting, and this is actually it provides metrics towards how many times or how much memory a process has used, or how many disk operations it does. So if you're wondering where your Amazon Web Services invoice comes from, how they calculate that, look at that. And it also allows you to control processes, so you can freeze and restart processes with C groups. Linux containers, so like I said, it's just a package, so you can just install it. It's not really part of the kernel, but it's part of most distributions of Linux, and it can be a little bit different. So that's yeah, it can be different across different distributions. And in 2013, there was a redesign for the kernel, and so these are the kernels also used for that minimum required for Docker, and they added namespace isolation. So they added a feature to isolate the process ID, the host name, the file system, all the network interface, the user namespace, and that's also why Docker was made possible. So the first Docker release was made by Solomon Hykes in 2013. It was great, but it depended on those Linux containers, which could be different. And so they said, okay, we don't want them to be different. And so we wanted to work it on every distribution. So they abstracted that with something written in Go. They wrote in Go called libcontainer, which provides an additional interface above LXC. I think nowadays they use runc as their default container environment, but you can choose your own or write your own if you want. So let's talk a bit about the benefits of Docker and the containerization. So, of course, the first benefit is scaling. It's very easy to scale your application, because all you need to do is just Docker run your application, execute, and you'll have multiple containers. It will reuse the same image. Your image starts up in a few seconds, and it's available from everywhere through the registry. And you don't have to manually install everything on a server anymore, because everything is packaged inside the container, so it's very easy to scale. Another thing it enables you to do is immutable infrastructure. And what's immutable infrastructure? Sometimes it's compared to Lego. So if you build something in Lego, and if by some reason, and if that's possible, a Lego piece breaks, you just replace it. So what this allows you to do, if you have like a lot of containers running and something goes wrong inside a container, instead of having to go in there and see what went wrong and having to fix the problem, you just throw the container away and you just run a new one. So it can self-heal. DevOps. There's a lot of benefits for DevOps. One, the developer only has to take care of what's inside the container, so he can choose whatever is inside the container. So if he says, hey, I need Java 8 or I need Node.js, as you just, and you want to say, I also need that Ubuntu or whatever, you can just put it inside the container and then give that container to the ops engineer, and the ops engineer just does not have to care anymore about what technologies it uses. It just, he has to know, like, okay, there's an application inside, it exposes port 80 or whatever, or maybe another port, and maybe it needs a volume that needs to be mounted on top of it, but he doesn't need to know anymore that it's a Java application or whatever. He just take the container and run it on any server he wants. Continuous integration. So you have the same artifact for all your environments. A Docker container running on your local laptop or on production will behave exactly the same way. So you no longer get, oh god, something went wrong in production, and yeah, it worked on my laptop, so I don't know. you can use this same artifact to deploy to your development environment or your testing environment and to production. But you can also use it to do other kind of stuff. So if you have, for example, a build tool like Jenkins or CloudBees, you can configure those to use Docker. You can also run them in Docker as well. But you can configure them to run your builds and your tests and your integration builds or whatever, deployment builds, to use like a Docker file. You no longer need to have, like, if you have a server that has Jenkins installed, you no longer need to have Java installed or Maven inside that, on top in that server, because you can put everything inside the Docker file. So you no longer need to wait before they install it. Right, so those were the major benefits. And the next big topic is orchestration. So how are you going to manage a lot of containers? Docker provides a few tools for that. It has Compose, Docker Machine, Swarm, networking. And the first one, Docker Compose, is a very simple one. It allows you to write a file and that contains the definition of, okay, I want to run these containers, and I want to link them like that and stuff. So I want them to work like that. It's great for single host, but for multi-host it's still experimental. But I'll show you. So I went to a certain blog post about Docker, the latest Docker Compose, and they had this great example application, which consisted of multiple applications. So the first, it's about voting. It's about cats versus dogs, you will see soon. And the first app that shows the results of the voting is a Node.js app. The second app, where you vote, is a Python app. I think it uses Flask to render as a web server. And the third is a worker app, which is written in Java with Maven. And if you look at the compose file, you can see the services defined. So the first, my voting app, and I can say, hey, I want to build from there. So there's my where's my Docker file located? So come on, how about you? All right. So this here points to this Docker file. If you look at that, it just starts from Python. It sets the work directory. It adds some files. It runs some commands. Adds some more, and exposes a port and defines the commands. That's all it does. You can also, in the compose file, you can define the ports to redirect to. You can say that it uses a Redis, so actually the service Redis, which is defined at the bottom here. And it connects to
two networks, but I'll talk about networks later. So, and the same thing for the results app and work app. So maybe wait, I'll just I'm gonna let it run first because else you may have to wait a bit. So to get this running, all I need to do is docker compose up detached. So first thing it does, create some networks. It starts downloading everything. So let's just let that run in the back for now. So how does this application work? So you have a voting app, and it talks to a Redis, and then you have a result app, which talks to the database, which is a PostgreSQL database. And then we have the worker app, which talks to the database and the Redis, and it synchronizes the voting from the Redis to the database. So it's actually 5 containers working together. So currently it's just downloading everything. I'm glad the speed's okay, so we would be waiting really long. Just let's look at the other Docker files. So for example, this node.th app does pretty much a similar thing. It starts from a node base image, adds some files, runs some commands. For each command that you do here, you create a layer. An optimization that you can do if you have multiple run commands is you can just do this with everything on the same layer, and then you only create one layer. Now this used to be really helpful to create smaller layers, but with the new content addressable image ID system, it's no longer needed. And if we look at the worker app, it actually does something that I would not recommend. So it starts from Java, it does some updates, no problem, but it actually also runs Maven, which means for some reason, so it installs Maven and then it executes it. So you're gonna have a big image because it will contain Maven as well, but you don't need that when you're running your containers. So what you should do in your build is you can do all these things. You can do a Maven build, but make sure that the target or what you create is outside of the container, and then start a new create a new image based on what came out of this one. So you can do that with Jenkins or Cloudbees or whatever. So now I'm gonna have a really huge image, sadly. It's still going, so it's actually doing the Maven build right now. Yep. It's adding the source code. Okay. And it's compiling, so it's running some tests. Okay, now it's doing the voting app. So Python. Now, of course, this is the first time we do this on this Docker host, so it takes some while. But if you do this on, while you're developing an application, this will only take, it's only the first time. The most images will be built already, and you'll see when I take it down in a minute and back up, it's going to be much faster. It's going to be up in a few seconds. So, of course, if you make changes to your code, and then it's going to rebuild the images that you changed. default node package warnings every time, indeed. Right, there we go. So now I have a lot of containers running. Let's see. This. So I go back to my localhost and I go to port 5000 and I go to 5001. I have my voting app and my result app running as a container. If I vote, oh god, no, I'm a dogs person, so you can see there's a vote for dogs. So the vote went all the way through Redis, through the worker, to the database, to the voting app. Great. So if we take it down, there you go, it stopped. You can put it up again. It already created images, so there we go. I did not detach it from the terminal, so it's now running again on my terminal. It's available. There we go. So that works. Awesome. Thank you, demo gods. Okay, so back to my presentation. So I will show you the multi-host version later, but I first have to tell you a bit more about some other tools. So, okay. So the second tool is Docker Machine, and it's a very useful tool to create new Docker hosts. So it creates new nodes and provisions them with Docker. So what it does is just, okay, you can create multiple machines and then say, okay, you guys run some containers, it's no problem. That's all it does. And they have drivers for a lot of different infrastructures. So you can use Docker Machine to create new nodes on Amazon or Azure, or like I did locally, VirtualBox, Hyper-V, DigitalOcean, all the major players that have that offer infrastructure as a service. So the third tool is Docker Swarm, and it's a clustering tool. So because you can create machines with Docker Machine, but they're just standalone. They can't talk to each other by default. So you need Docker Swarm to set up a cluster and be able to let them talk to each other. So how does it work if you want to use it? If you have set it up, you can just connect to one swarm manager, which is also just a host with Docker on it, but it's called a master, or the swarm manager. And when you say, okay, run a container, then it will figure out which host is best to run it on. You can modify this behavior a bit. By default, it will just spread the containers, but you can also label your host. So you can say like something, this host is a production server and it has SSD storage or whatever. You can define anything you want. And then you can, when you run it, you can pass in some constraints, and the swarm manager will figure out, okay, you have these constraints, I will look up for a host that has those, that actually is sufficient for your container, and it will run it if it finds one. So next to normal constraints, you can also set filters. You have two types, node and container filters. So when you run a container, you can say, okay, the first one I showed, constraint. So I want, like, for example, a host with SSD or whatever. I want a healthy one. But you can also have an affinity filter. So I say, okay, this image, this container, it calls a Redis. So I want it to be hosted on a server that already has Redis running.
So it's like, okay, you can do that. Or you can say, I only want it to run on a host that has a port available at a certain port or whatever. Or you can also use dependency filter that says, I only want to run this container where the Redis image has already been pulled, already downloaded. So, and you can also use all kinds of regular expressions and all kinds of stuff, so you can do some really crazy things with it. And the final tool, it's not really a tool, but it's a feature that was introduced in Docker 1.9, is networking. So before networking, you could connect containers to each other using links, which are bridge networks in the background. And they would like say, okay, they would set environment variables inside the container with like the IP of the other container, and it would create an entry in the host file and stuff like that, but it was not really stable. It's like, for example, if you take down one of the containers that was linked, you put it back on, it received a new IP and it couldn't talk anymore, so you had to take down all the containers and put them back up. So they fixed that by using networking. And it allows you to create overlay networks, so you can just create a network with a certain subnet, and your host will be able to see it. If you can just say, okay, this container must run on that network, it will magically work. And they fixed this by embedding a DNS server inside the Docker daemon, so they no longer use the host file or whatever. So every Docker daemon has a DNS server embedded. You can also use network plugins. So if you want to use all different kinds of networks, you can like a Weave network or a virtual private network. You can also do that. So let me show you how to set up a cluster and how to run multiple containers on them. So, okay. So I created a script because it's a lot of commands, a lot of long commands. It takes about 4 minutes to execute, so I'm just going to execute it also in the meanwhile while I explain it. So this script, it uses Docker machine to create a few machines using a virtual box driver. And the first one I'm creating is a key value, a machine to use as a key value store. And as a key value store, I run console inside a container on top of that machine to act as the key value store where all the machines and all the containers and all the machines and the networks going to register themselves onto. Then when this is ready, I create a swarm master. So you can pretty much do it by saying, okay, this is going to be a swarm node and this one is going to be the swarm master. And you have to add a few properties to it. So I'm going to say, okay, the console is running there, and that's going to ask the IP of the key value store. It's running on port 8500. I have to say the store is running there, and I'm going to broadcast myself on top of this network interface. So you can imagine why I prepared this already and did not learn this. And what I'm also doing is, when I'm creating a machine, I'm labeling it. So I'm going to say this is my production server. And it's going to see it's going to be my front-end server. And then I do the same thing with 2 more machines, but those aren't the swarm masters, so that's working. So it's creating node 1. After this one still has the two nodes. And then at the end, I create 2 networks. So I create a front tier network for my front applications and a back tier.
And I also define a subnet, and you must do this. When I was trying to figure out, I was trying to get this up and running, and my containers could not talk to each other across hosts. And I was like, oh god, why? There's nowhere in the documentation to do this. So in the end, I found some examples somewhere, and they said, okay, you must define a subnet, or you're gonna have a lot of connection issues or conflicts, because yeah, it's gonna be really conflicting. Okay, so it's the third node it's making now. So there's one more. You can see what it does when it creates a machine is, okay, so it copies the use VirtualBox, so it copies the image of VirtualBox. It also automatically sets up SSH keys. And when this is done, it starts a VM, tries to acquire an IP, waits to be provisioned with the Docker, and then it also copies the certificates to your local machine and to the remote machine. And after that is up and running, it's good to go. So now it's doing the final one. Yeah. Just tricky now. Any questions yet, by the way? No? Almost there. See, it's like normal virtual machines are really slow, so use Docker. Almost there. There we go. So if I ask Docker machine to listen, you can see I had a few machines already, but now I have a key values machine and 3 nodes, and node 1 is the master. And if I want to connect to a certain node, I just say Docker machine. I alias it, by the way, so because I don't want to write the whole command every time. You can ask for the environment that you need to set up. So for example, for node 1, this is if you want to just connect it to node as swarm. If you ask for the swarm, if you want to connect to a swarm master, you just pass in the swarm flag. And which means it's the same actually. So, but you start, it's just the same. No problem. Oh no, it's a different port. That's why. There we go. So if I want to start deploying stuff on my cluster, I need to evaluate the script that Docker machine provides for me. So I just say Docker evaluate the environment. There we go. And now I can see that there's a few containers running inside my cluster already, some swarm masters, swarm agents. So it's great. And now if I want to run my my voting application, I can also do that with Docker Compose. And I will show you how I defined it. This may take a little bit, so let's hope it downloads everything fast. So, in the meanwhile, so I had a lot of problems setting this up because it's experimental. It's not really supported yet. The first thing you cannot do is like say a build. You cannot add a build property to your service because you have it locally on your machine. It's not on the host, and you don't know where this image is going to be built. It can be on any host. So it can only run containers from an image that it can download from Registry. So I had to push my applications, which I already did, to the Registry. So that's one difference already. You cannot use the links anymore. So in my earlier example, this one, you could set up the links. So with bridge networks, you cannot do that anymore. You have to use the network interfaces now, because there's a bug somewhere that says, okay, if you link it and that one node is on that one, and that container is on another one, it's gonna say, hey, I can't find a certain host anymore, so it's kind of sad. You can, so what I also did here is define some constraints. So for example, I want this voting app service to run on my front end service, so I just put like type is front end. I'm connecting to the front tier, the back tier, because I need to be able to also talk to the back end. And same thing for the other images. And for the database, I said, okay, it's a database, so I really want to make sure it's on a so-called fast disk, so I said, run it on an SSD. And since I already declared the networks with the subnets in my other script, and over create, I just have to say, okay, I'm just going to use some external networks. And so you have to define like a sort of a little mapping between those networks. So, oh, it's already done. Nice. It was really fast. So, I have, now look at my cluster. I can see that all my containers are running, and it added like a voting app swarm underscore, and then the name of the app, and then like a number. So normally you would be. I think I can scale it. I hope. Let me see how that commands works again. So if you don't know, you can just use the help. Okay, scale. Okay, so I can just, I hope it works. Scale worker to 3. There we go. I just scaled my worker container 3 times. Look at that. You can see them running here. So it's very easy to scale your container. So if I want to go there now, right, so I first gonna need the IPs. I have no idea which one it is, so okay, so it's these are my nodes. So I think this one's my front end. No, maybe the other one. Okay, so this one's running there, and no, 1 0 too much. There we go. So now I have my application running inside my cluster with the nodes on different hosts. So if I vote here, dogs, because I'm a dog person, it votes. All right, awesome. So, yay. But of course, managing a cluster through this is kind of bothersome. So there are better tools to do this. So one of them. Okay, we'll talk about it in a minute. But so the setup that I just did, is it production ready? So the compose tool and the swarm tool, it's not. So when I was setting this up, I had so many troubles. I think I spent like the whole day trying to just figure out one issue, because what's happening? And I wanted to report this. I finally figured out, okay, if I do this and this, then it does this. So I wanted to report it, and someone just beat me to it like 5 hours before me. So I wish he had reported it earlier, so I would know like it did not work. So what the problem was that the swarm engine, if you stop a container, it does not remove the port.
so the port stays unavailable, while the Docker Compose engine it puts like a constraint um, on top of that service that you defined, and it wants always to run it on the same node. So if you try it again, you're gonna say, hey, even though that container is stopped, the port is unavailable, and it was like every time I wanted to try it, I had to take down my whole cluster and recreate it again. So it was like, ah, goddamn. So I spent a lot of time getting this working, but yeah, there's a lot of limitations, and I would not use this setup yet in production. But it's coming. So another thing you can use to create a cluster is a Docker Cloud. So let me just show you that. Well, I've already got it set up because I don't want to take too long time. So I'm just gonna go to cloud.docker.com, and the first thing you do after signing up and entering maybe your credit card is linking your account to a provider like Amazon or Azure or DigitalOcean. I took Amazon because I already had it. So you can say, okay, here we go. You can use, you have a free plan, so you can start without a credit card if you want. Oh God. So what you can do easily is create a new cluster. So let me just try that. So I'm just gonna say, hey, demo. I'm gonna use my Amazon Web Service. I want to run it in Europe, West Europe. So that's gonna be Ireland, and maybe want like two small ones and a bit of disk size. Okay, launch. There we go. And then it creates the nodes and provisions them with Docker automatically. It takes a few minutes, but I already had some, so just continue. So I already have my voting app running. It was actually really easy to set up. So what you do is just create service, for example, my voting app, and you would get this screen. You could say, okay, I want this image, that tag, and no stack yet, but that's available now already. And you can define, okay, where do you want to deploy it, which port do you want to publish, do you want to have a restart policy, like, okay, sure, always restart it if you want. You can define which process ID it gets. You can even override the run command in the entry point, so if you have like if you want something else, so you can define multiple services using the same image, maybe with some other commands. You can easily limit the memory or how much shares of the CPU it gets. So it's based on 1024. So if you set it to 512, it gets half of the CPU. So just no limit. So I created all these services, all 5. It was very easy. And then I created a stack. And the stack is very similar to Docker Compose. Let me show you. So you define your services like the same names, DB, and like say, this is my image, and these are the ports, and that's all there is to it. And you say just deploy, and Docker Cloud will figure out everything for you. So it's gonna say, okay, these are my services. These are the available nodes, so automatically deploy them. And so you can see it's now deployed on, it's running somewhere here. Wait, I'm just gonna redeploy it just to show you. Redeploy. There we go. This may take a few minutes. If you go to a service, you can do a lot of things. You can view the logs. The logs here. You can create triggers. You can see what happened to the stack or to the service. View the configuration. You can see which containers the service is running. So
Let's see how it's doing. Okay. So redeploying everything. It's very easy. This took me about 5 minutes to set up everything. So I was using Docker Machine and Docker Swarm, and networking took me more than a day. So, so it was much easier. Okay, it seems to be running. So if I go here now, then it's one of these. Okay, so this is my voting app, and this is my result app running inside a container. So, hey, so I'm gonna post it inside the chat. So, which one was that? The result app. I think this is the. Oh wait! Oh god! I think the first one was wrong. Sorry, this one. So these are the two apps. So if you can go there, I'll just show it here. Oh god! You guys are voting dogs. That's good. No, not cats. Yes, more dogs, please. Great, awesome, crazy. Thank you.
No dogs.
Awesome, it works. So if I go look now at my nodes, you can see every container is running on a different node. I have 6 nodes. I have a total of 5 containers, and so they're all running on different nodes. And I did not have to do anything with networking or whatever. It all figured it out for myself for me. Now, if I go to Amazon, you can see. I have in my Amazon console, you can see I have 6 running instances, and for each instance, set up everything, including the VPCs, and added some tags to know to which cluster and whatever it belongs to. But there, very easy. So now this tool is great for small applications. It's not really useful to deploy thousands of nodes or 1,000 different applications. So there are better tools for that. So, and one of those I'm going to be talking about now. I will sadly not be showing them, but so there are other tools that you can use. And the first one is Kubernetes. It's my favorite. It's created by Google. It's written in Go. Google used to start 2 billion new containers every week with this tool. So every week Google has 2 billion new containers that starts and stops. So really, it's really crazy. So if you look at how it works, so Kubernetes sort of works the same as the Docker Swarm and Docker Machine, but it does a few different things. So you have your master and your minions. The minion is just a server that's running a Docker host, but it also contains a kubelet and a proxy. The master is like the swarm manager, and it contains etcd as a key value store. So I used console earlier with Docker Swarm. Which you can also use etcd, by the way, with Docker Swarm. You can also use Zookeeper, but Kubernetes uses etcd. It has a scheduler, so if you go to the master and say, hey, I want to run this pod, so a pod is a collection of containers, it's like a service. It will figure out on which minion to deploy it, so which one's healthiest or has a certain affinity. And there's also a replication controller that will check how many pods are running of a certain instance of a certain pod are running. So if you want to say, hey, I want to run this pod 4 times,
So check on, okay, is it running 4 times? Okay, no, it's only running 3 times, and we'll schedule a new schedule to run a new pattern on the minion. And it does this by talking to the kubelet. So the kubelet gets a command, hey, can you run this pod? And like, okay, and then the kubelet goes to the Docker host and says, okay, run these containers, and then sets up the proxy. And if your users go to your application, they first go to the load balancers, which you can also create with Kubernetes, and they go to the proxy. So you just select a server that has your application running, and they go to there through the proxy and then to the containers. And it all does this for you. So it's really great. Another one is Core OS. I have not used this yet, but it's also really good. You don't need to use Docker with it, but you can also just run normal containers, Linux containers with it. So it works very similar, except that each worker, each minion, each node, each host has etcd installed. So not only the master, but also the hosts, the normal nodes. So each node has a complete knows where all the other nodes are. They keep each other up to date, and you don't have a single point of failure. If the master goes down, the fleeting, then you can keep working because there's still other key values on the other hosts. And the fleet daemon is something very specific to CoreOS. So I don't know if anyone of you knows systemd or has heard of it. All right, a few people. So systemd is like a daemon that manages other daemons and so you can start and stop services on your host. But it's only on a single host. So what they created for CoreOS is a sort of systemd that works on a cluster level. So it's really great. Next tool, Lattice. Also awesome. Also I have seen it in action earlier, so it's really great. Looks really good. It's a different distribution of Cloud Foundry. So, any one of you have heard of Cloud Foundry? Or have used Cloud Foundry? Okay, awesome. So that is very similar, just a little more lightweight. So it has like the Bosch light and stuff like that. It also has the router, the log aggregator. And yeah, but the thing is they don't really focus on security, so I'm like, okay. So they say that it's really in their facts, so we don't care about security, that's your problem. So we had a talk last week about Cloud Foundry here, so you can still view that on our YouTube channel. Next week we're gonna have a workshop, a hands-on workshop about Cloud Foundry. So if you watch those, you'll be able to use those, and Lattice is nearly the same. So be sure to watch next week. So the last tool I have to talk about, which is also very important. So like I said earlier, volume, you need to write your data to your volumes. So for your databases and all that stuff. But what do you do if like your container goes out of memory or whatever, and it gets rescheduled on another host? Might happen in a cluster. So you can have your container running again on a host different than what it was originally running on. So it gets detached from the data it was watching. So you can use Flocker. It's a very advanced volume manager. It works really good, and it will make sure that the container and the volumes stay together. So if you want to move a container also from one host to another, Flocker will allow you to move the volumes with it. So get sure that your data stays with the correct container. Okay, so those were a few tools I wanted to highlight. And I want to talk about one more thing, and then we're done. I'm going to show a little bit too, but not much. Is Docker security. So security is really important. And you can view Docker security with two things. So first you have your container security. So containers by itself are very secure already because they already isolate a lot of stuff from other processes. So you isolate your file system, the user namespace. It doesn't export ports by default. It's very isolated by default. So it only has the dependencies it needs to use. So it does not have any other code available that it can use to create a security vulnerability. Second profiles, I will show you this in a minute because it's kind of hard to explain. So it allows you to prevent some system calls. And coming soon, there will be unikernels. So what I told you earlier that like all the containers use the same kernel, like with the bootfs layer, it's not always true. There's already an experiment going on, a working example somewhere on the internet that has Docker containers using unikernels. So what's a unikernel? You can, instead of using the same kernel, you can create your own mini kernel, and you can strip all the features from the kernel that you no longer need. And why is this so important? Because you may write a hello world application, just for example, but the kernel beneath is maybe like 20 million lines of code, and there's like a lot of base to create a security from maybe somewhere here or somewhere there. And if you strip like most of the kernel features, you reduce that amount of base that can be used to be vulnerable. And the last thing is, how do you deal with security patches? So, for example, your application has suddenly there's a security vulnerability that needs to be patched. And so what you do, you fix it in your application, you create a new image, and you deploy it. You take out all the old containers, you run new containers with a new image. But make sure you remove the old containers, but also make sure that maybe you also remove all the other old images that has the security vulnerability. Because if those come up again, then you're still gonna be vulnerable. So you need to keep that in mind. The second thing you need to consider is node security. So not only the containers and the images, but also the host and the host that's running the daemon, because the daemon must run as root, which is, well, never run something as root, as they always, right? So they're working on that so that you can run Docker as another user, but currently you must run it as root. And the default authorization is like everything or nothing. So if you manage to connect to a daemon, you can do anything. So if you can get onto a daemon and connect to the swarm master, you can pretty much do anything on the cluster. So they fixed that, sorta, in 1.10. It's still everything or nothing, but they allow you now to write some authorization plugins. So you can write a plugin that requires some credentials or like an LDAP or whatever. But I have not seen one yet, so feel free to do. And that's about it. It's about security, but I will show you those second profiles because I thought it was pretty cool. So it's really low level stuff again. So all right, so I have this file, it's a JSON file, and it's very small. And what I do here is the default action is I allow any system call that the user can do, and the system calls, the other system calls, like this change modifier, I say no, you can do that. So how would I be able to use this? So if I would run this command and I say okay, security opt, so security option
secomp, and I define, okay, use this JSON file, and I'm gonna run busybox. No, wait, I'm gonna run a Debian Jessie version, and I'm gonna execute the command not400 my host name. I think. Right. Oh wait, yeah. We cannot do this. So let's quickly gonna download Jessie, Debian. So did it do something? Ah, wait. I have to attach the output to my terminal. So I can just do that here. So did I do it? Did it work? Did I screw it up? So I'm gonna shoot. It can happen. Can't know everything. So maybe because I really need to use it busybox. So okay, so I had to use busybox. So you see now, it said, okay, operation not permitted. I'm not allowed to change the modifier of my hostname. So why is this so important? There are certain commands that you should not be allowed to execute. So there is, if I say, okay, let's run without a security profile. It has a default one, but now I said, okay, I don't want you. So, and there's this command called unshare. Does anyone know the unshare command? No? So it's a very special command that allows your process to go outside of a certain execution context. So for example, you can go outside your pit namespace or your user namespace or your mounting namespace. So for example, if you would do this on a mounting file system, if you would unshare your mounting mounts, you would be able to get a copy of the file system and maybe even view files that the root user cannot even view. So it's a very dangerous command. So it's like bit user and echo hello. So it's like hello, and if I just write like this, like operation not permitted in share. So you can open system calls or you can deny system calls with it. So depends what you want to do. So you can also, for example, prevent the container from creating new user and stuff like that. So that's about it. I think that's all I have to share about Docker. So one more thing. So how does the roadmap still look for the future? So like I said earlier, Docker 1.10 was released last week, which contained a lot of cool features and some bugs as well. And I went to visit the GitHub and the Docker website, and they just don't have any plans yet. I was like, you guys don't know what you want to do? I'm like, no, apparently not. So I think they're just working on like the Docker Compose and the Swarm compatibility. And if that works, it's going to be really, really awesome. But for now, there's nothing major inside. So yeah. Yeah, disappointed. So thank you for watching and listening. Anybody have questions, or have there been any questions from Twitter or? Oh, sad. Well, that makes it really easy for me. So thank you.